Today we're going to learn about FLAML, which stands for Fast Lightweight Automated Machine Learning, which is an AUTOML library from Microsoft. It's tightly integrated in Microsoft Fabric and also part of the tutorial, and also the .NET machine learning library, and received plenty of attention throughout the last year. You might wonder, on the website there were 3 speakers listed. Zheng and Markus unfortunately could not make it to Paris this week, but we have Jiang. Unfortunately, he's here from Beijing. From Beijing, and he's a senior software engineer at Microsoft, who will actually show us today how we can do automated machine learning and tuning with FLAML. I'm really excited, and the stage is all yours.
Thank you, Markus, for the introduction. And good afternoon, everyone. So welcome, thank you, and welcome to the tutorial. And I will, as Markus just mentioned, so at the beginning we planned to have 3 presenters, but one of them got COVID just the day before we departure, and the other is has a heart conflict, so I will be the only one to do it today, and hope you will enjoy it. And so let's begin. So today I will do the tutorial in 3 sections. So the first one, I will first start with the overview of AUTOML in Microsoft Fabric, and covering the scenarios of tuning and AUTOML. And then we will also introduce how these scenarios can be accomplished in with FLAML, especially in the Fabric platform. And also we will go to a deep dive into the FLAML in Fabric. I will walk you through some advanced features. So I think today will be a hands-on tutorial. So later I will show you how to quick register into the platform, and you can follow me to try the notebook. And so in the end, I will also show some new features that we provided only in Fabric. So the first part, we will do the overview. So in this part, I will try to first let you know how we think about the AUTOML and what FLAML will help you with. So if we're thinking of general machine learning workflow, so the first thing is that you will need to get the data, and you will train your model and evaluate on the model. And then once you got the perfect model you think that can work in your production, you will then do the deploy and prediction. But before the deployment, the most important thing is that you need to do a lot of dirty work on preparing the data. And then you need to choose a lot of parameters from the models. And also the model itself is also need to be chosen from a lot of candidates. And then you will also need to do the evaluation, iterate on the models. So there are a lot of decisions to make to optimize the model performance. So like the select model, tune all kinds of hyperparameters. And so, like I said, there are lots of decisions to make. Like select model, there are like sklearn, XGBoost, LightGBM, and PyTorch. Also Spark models, SynapseML, all kinds. Now you have also large language models to choose for your tasks. So this is the first step, and then you will need to choose hyperparameters for your models. Like for instance, if you chose to use LightGBM, you need to maybe you need to choose how many the number of estimators, the number of leaves, and the learning rate. A lot of things you need to choose from the optional hyperparameters. So doing this iteration is actually takes a lot of time, and if you don't have the expertise on the model itself, you may need to you may spend a lot of time and end up without optimized settings. So this is what we want to do in FLAML. So by design, we hope that FLAML can help you to easily cover the AutoML and the tuning part. So you just need to care about data, you care about the task you want to accomplish. And FLAML will find you the best model with the best hyperparameters. And then you can do the prediction with it. So I think for those who have bring your computer, you may access this GitHub repo to, and I can show you. Let's go to the repo. So I have prepared 2 notebooks here in the tutorial, and we will have the AUTOML24 demo AUTOML task, and also this tune LLM. So these 2 notebooks will be the material we will use today. So I think you can like download the notebooks and try it. So FLAML actually first started as a research project in Microsoft research, and then it has been picked as a production solution I think in several products at least inside Microsoft. So for us, the Microsoft Fabric, I will introduce a little bit more about Microsoft Fabric later. We chose FLAML over the other frameworks, not only because it's a Microsoft production, also because it has a lot of SOTA algorithms behind it. So covering the hyperparameter tuning, offline tuning, like the meta learning, and also the all kinds of tasks. Yeah. So I will not go into the details of the papers because those are. So first, I didn't write all of these papers, and for today's, we want to focus on the application of FLAML. And so now we can talk about what is Microsoft Fabric, and you can access it with this one. So it will take you maybe 5 minutes to register and to get the. Oh, this is French. Let me. Yeah, you can register, click start free and register an account with your school email, university email, or your company email, and get free access for 60 days. So it's very simple. Like you can click sign in, and I think I have already, because I have already signed in, so it will direct me to the workspace I have. But for those, so this is internal site. So for you guys, I think you will see this one. So I also registered another account. So without Microsoft, with my university email. So this one is the one I have, and app.power BI. Yeah. So like I will continue, and for those who are interested, you can continue your registration process. And after you finish all the steps, you will see something like this. And if you click from the bottom left, you can choose from different features. And today we will use the data science feature. And so I will continue with the slides. Yeah, and AutoML is one of the features inside the data science product. So this is the docs for, this is the docs for the AutoML in Fabric. So it's actually depends on the FLAML AutoML module. And I will not go into the details here, but if you are interested, you can check here. So, and also we have the hyperparameter tuning, also is backed with FLAML and using the FLAML.tune module. So these are all the Python packages and Python APIs we are using. So it also supports .NET, but we will not cover .NET part today. So basically, we have already developed and applied the FLAML-based AutoML solution in different kinds of scenarios, like the retail and maybe product recommendation and demand forecasting and some of the finance use cases, and also the product development and security, like to identify the some of the security issues. Yeah, so basically, we find that FLAML can accelerate the research and development efforts, and it can also improve the productivity. And I think the most important is that especially for citizen data scientists, FLAML can help them improve the model accuracy, because if they do it on their own, they cannot find the best hyperparameters for the models. So and FLAML. So let's go into a little bit about FLAML itself. So FLAML is designed with two parts, so the tuning part and the AutoML part, and it will use other like third-party machine learning packages as a black box. So we will tune the hyperparameters for different models, and we have also provided some high-level APIs for you to use it. So, so this is all kinds of like advertisement. So it's like fast, it's save cost for you, and it has the very smooth customization. Like if you want to have fully control of the models of the parameters, hyperparameters, you can use the low-level APIs. And if you just want to do a quick demo, you can use the high-level API and get a faster trial. And also you can extend it with different models. Like if you find some models are not already integrated inside FLAML, you can extend it by yourself. It's super simple. So this is the high-level APIs we have. So for AutoML, you just need to so FLAML, sorry, FLAML is an open source project. So you can, if you don't want to use it in Fabric, that's totally fine. So you can just pip install it in any Python environment, and you can run today's notebook. So it should be okay. You run it anywhere. And for this part, you just need to import the AutoML, and you initialize the class, and you give the pass in the data set you are using, and you specify what kind of task you are. So we will cover about task-oriented AutoML. So you just need to tell FLAML what kind of task you are working on, and set some of the budget other parameters. And if you want to have fully control on your own models, on your own hyperparameter tuning things, you can use the low-level user-defined functions. So in this case, you just need to define the function you want to run by yourself, and you define the metrics and some other configurations, and also you can start with the training. And now, yeah, so let's go a little bit more about the task-oriented AutoML. So in the task-oriented AutoML, we defined it as, so you will have some constraints or settings on your resource, like if you have GPU or not, how much time you want to spend on the training, and also like how many CPU cores you have, on the resource. And also what kind of task you want to do, like it's a regression or it's a classification or it's a time forecasting and or NLP kind of training or large language models tuning. So you just define this kind of tasks. And of course, you need to prepare your training data. So you pass in the training data and the task type into FLAML. FLAML will automatically find the best model and the best hyperparameter combination for you. And it will, the output of AutoML is an instance containing the best model and hyperparameters, and you can deploy it with I think so. If you do it in Fabric, it's just one line of code, and if you do it elsewhere, maybe in your own environment, you can also use the use AutoML.fit to do the prediction. It's also super easy. Yeah, and yeah, this is the kind. So I think we have more tasks now, but this like for classification, we have more sub tasks. Like you can define if it's a binary classification or it's a multi-class classification. So the difference between that is that if you have different the best loss function for different kind of classifications. So this is for classification and for regression. Also time series forecasting, we have several kinds of sub tasks, and also the ranking, and this is all the kinds of like NLP tasks, and yeah, and these are all the kind. I think we have, yeah, basically we support all of these third-party machine learning libraries. We have integrated, I think more than 60 models from these third-party machine learning packages. So if any of the 60 models will fit your task, you can use FLAML to do the auto machine learning without any customization. So yeah, but some of the packages they are conflict. Maybe you cannot use all of them in the same time in the same task. Like for Spark ML and Synapse ML, they need Spark runtime to perform the training, and maybe for PyTorch forecasting you need a Python version lower than 3.11. So there are some conflicts between the packages, but if your task is clear, and you may just install the packages you need. And yeah, so here we have this. This is in our paper that we have done a lot of benchmarks. So to compare the performance between FLAML and the other like AutoSKReN and Cloud. So this is actually AWS solutions, and this is HB band and L2O and TCOP. We have compared our performance with others. So in the figure, like if you see positive difference, that means FLAML is better, and we can see that in most cases, FLAML performs better in it's like you can get better performance both on the accuracy on the metrics you choose, and also it costs less time. So this is why we named it fast and lightweight automated machine learning package. This is the name FLAML came from. Yeah. And so to summarize a little bit, for the task-oriented AutoML in FLAML, we think that we found that FLAML can minimize the manual effort to train a model, and it can also improve the effectiveness and the efficiency of the training process, reduce both the computation resource and the time. and also it supports the customized metrics and customized learners or models with simple, very simple plugin functions. And yeah, so before we start our demo, I will go a little bit more about how FLAML works with task-oriented AutoML. Like, so in the workflow, you will have, so from right to the right, from left to the right, you will have like design the resource and the budget and the ML task. This is the input, and the output will be the ML model. But inside this, we will leverage the third-party packages to do the training, the fitting. But what FLAML helps is that FLAML will select so estimator means the models. So FLAML will help you select the models for based on the task and the resource you have set, and also it will then compute the loss with the third-party package, and it will then get performance on the current selected hyperparameters combination, the hyperparameter combinations, and then it will use the search algorithm to estimate the config, and it will then choose a new config based on the loss of your current selection, like the model and the hyperparameter. And so after several, maybe hundreds of iterations, you will finally get the best combinations. So this is how FLAML finished the work. And yes, and also the next part I will introduce the tuning part. I think maybe we can, at the beginning I thought I would like introduce the demo, because we have two persons. So the first part I will like introduce the theory part, and then we will do the demo. But since now I'm the only one doing the presentation, I think we can now cut into the demo part, and then we can go back to the other part of the basic introductions. So let me open the notebook. So if you have already like downloaded the notebook, it doesn't matter if you are using the Fabric or your own environment. That should be both okay. And in this notebook, so the demo AUTOML task, like we need to, let me write. So for this demo, because I will use OpenML to get the data set, so you need to install OpenML, and we will use some features that requires sklearn new. So you should have a sklearn version larger than 1.3. And for some of the other features, we will also use the RGF Python. So yeah, let's see. Okay. So once you install the dependencies. Oh, I didn't install FLAML because we have FLAML already pre-installed in the platform. So if you do it in your own environment, you also need to install FLAML. Just people install FLAML would work. And okay, so let me do some presetting. So I don't want to see a lot of unrelated logs. Yeah, and because FLAML will integrate with MLflow, this should be this will be covered later. But I think it's okay. I can first show you the code, and then we go to the introduction of this part. Maybe that you can learn it easier. So for the you may don't need to set this in your own environment, but if you want to see the how FLAML leverage MLflow to track the training process and even the prediction part, you will need MLflow as well. So now in this demo we will use the airline data set to predict whether a flight will be late or not. Will be late or not. So first, you need to import load OpenML dataset from FLAML AutoML.data, and you can get the X-train, X-test, Y-train, Y-test with load OpenML dataset, and the dataset ID would be 1169. This is the airline dataset from OpenML.
Sorry, could you zoom in a bit?
Oh, sorry.
That'd be hard for me. I'm visual.
Yeah. Yeah.
Thank you.
Okay. So don't worry about the code because you can actually download it from GitHub. So yeah, and now we can take a look at the data set. Like it has several columns of information, like airline name as the code. This is actually the flight number, but yeah, so it's when after loading it has been recognized as a float number, but it should be integer actually. But it doesn't matter. So we have the flight number and we have the airport from. So this is the destination and also the destination, and also which day is this, like day of week. And also we have the time. So the time is start from 0 to how many seconds, how many, I think this is in minutes or in seconds. In minutes. So this is so it splits the day into minutes, and this is actually the time represents the departure time of the flight. And this is the planned duration of the flight. And this is whether it's delayed or not. So this is the data set. And to do the training part with FLAML, you just need to install import AutoML and initialize it. So this is 2 lines of code. And then you can set up the sign of. So this is the what I have showed here is the very simple combination of the settings inside FLAML. Actually, FLAML has a lot of parameters that you can choose to optimize your training process. But if you just want to do a quick demo, maybe you just need to set at the time budget. So this is the total running time in seconds that you want it to run, and also the metric. Like so, for this one, we choose like accuracy for the prediction, and this is obviously this is a classification task. So if you want to see the results, if you want to reproduce the results, it's not fully guaranteed that you can reproduce the results from different trials because there are some randomness that are not controlled by this seed. So this seed only controls the settings inside FLAML, but there are some settings outside FLAML in the third-party package maybe, but you can set the seed to better reproduce the results. And then you can start the training with these lines of code, so AutoML fit, and you pass in the X-train and Y-train and the settings. And oh, sorry, I didn't run so I ran this before in the morning. So, and let me run this, and also run this. And here we can also Yeah, so it will download the data set. It's, you can just ignore this one. Okay. Okay, get the data. And also we run this. And we run sets, we set the settings, and we can start running. So from the log, like you can see that for task, for the classification task, we have like light GBM, random forest, extra boost, extra tree, and another extra boost model, and SGD cat boost, and the linear regression models that can do the classification task. So the best models will be chosen from one of these model, and it will also train the, so like for the first trial, it choose the light GBM as a model, so it will optimize or try to find the hyperparameters for light GBM. And once because this is a simple data set, you can see that the light GBM handles it very well. So it's still trying to use light GBM to do add the estimator. So if in the real data, if you have like hundreds of trials, it will first try these models one by one. And for the first one, when it tries the combinations, the hyperparameter combinations for one model, it may try several times. Like maybe it will try, so it depends, but let's say it will try 10 trials for one model. And when it finds that this model cannot be the performance of this specific model cannot be improved based on the constraints you have set, then it will try another model. So now we can see that. So we set the time batch to be 2 minutes, and it's already 2 minutes, it didn't finish. Why is that? Because we like the time when we do in the training part, it will find the configuration, and when it's working on the configuration and the time, maybe the time budget exceeded during the training, it will not like finish the training. It will finish the training and then stop trying another trial, another combination of the configurations. So it will finish the working it's doing now. So now it's finished. And we can see that we have we have seven runs in the for this trial for this data, and in the 2 minutes. And here you can see we have the experiment, and you can see the results of the trial. So since I have run this several times to make sure make sure the notebook will work in our tutorial session, so I have run it several times. And this is what we just see is 10 p.m. Well, because in Beijing time is 10 p.m. So yeah. So this is what we just ran. And for each of the trial, you can see that this is the metrics it has been used during the training part, and this is all kinds of parameters that have been tried for this model. Like here, I think we are okay. The only like GBM models have been tried in this year. So like for this is in this trial, it's using it was using like GBM as the model. And this is the all the parameters is chosen for light GBM model, and this is the input schema for the data set and the output schema. And I think in the early trials, I have got more than like GBM tried. Let me, yeah, like, so in this trial, it's using SGD. So, and you can see that it has different parameters because SGD has different hyperparameters from like GBM. So you can see different parameters. Yeah, this is basically like what you will see from the runs, and we have we have improved the ML flow integration for the tracking. ML flow has the auto logging, and we have improved the auto logging part of ML flow to make it better fit with FLAML. So if you don't use FLAML's AutoML, because during the trial, actually, if you have the cross validation for one trial, you will have like more than it depends on the setting. Maybe you have three runs of model training and fitting and evaluation for one trial. So when I say one trial, it means one combination of the configurations, or like the hyperparameter and the model itself. So for one trial, you actually train maybe 5 models, and then you compute the average performance of the five models, and then you say, okay, this is your performance for this one trial, for this one combination of parameters, and that would introduce a lot of unneeded runs. It's just not clean. So we introduced we have improved that for the ML flow integration. And we also organized it with the parent run and the child runs. And we also, like, you can see the models, and because there are some featureization parts inside FLAML. So we also have this feature transformer and label transformer locked for you to do the final prediction. So in this AutoML pipeline, you get everything packed together, including the feature transformation and the model itself. And if you want to use ML flow to deploy the model, you can simply like deploy the model with ML flow from this folder. So that would be very simple. Okay, so I think this is the okay. Yeah. Also, we can see the results of the training. Like the best ML learner is like GBM, and we have the configuration here like 66 estimators, and for number of reefs is 4, and yeah, learning rate here, and also the lambda alpha parameter, and the best accuracy. It's not very high because we just like trained it for 2 minutes. Yeah, but you got a result, right? And it's not a random result, so because it is larger than 0.5. So, and also here is how can you doing the saving the model with ML flow. So ML flow is also an open source package. You can use it anywhere. And you can load it back. So, and you can also like do the prediction on your test data. And you can also compute the performance on the test data set. Yeah, so if you notice that the values here is different from what we have printed out earlier, because like I said, the random seed is used to help you reproduce the training, but there are some other randomness that cannot controlled by FLAML itself. So So here we didn't really reproduce the results I ran in the morning. But yeah, but the results are similar. I think the AUC is 0.7 before in the morning. Okay, let's go back to the slide. Yeah. So this is the AutoML and a quick example of the AutoML training with FLAML. And now, if you want to have more control on your training, you can introduce your own function, and you can use the low-level API, the tuning API, to help you find the parameters. So so here is the comparison between AutoML and tuning. So in AutoML workflow, you just need to define the resource budget and the ML task. AutoML API will help you to select the estimators, the models, and also find the combinations of hyperparameters, and do the estimation, and then choose another choose another better parameter combinations. But for tuning, you need to define the not only the resource budget, you will also need to define the search space and the function you want to evaluate on. So actually, for AutoML, it's also leverage this tuning part. Like once it choose the model, so the model is like the user-defined function, and it's also we have predefined the search space for the models, like about 60 different kind of models. We have predefined the search space for those models. So like we did this search space and use defined function for you, so it becomes AutoML. But if you do it by yourself, you define the search space and function by yourself, you are doing a tuning part. So it will be the hyperparameter optimization part. And here, so for the tuning, you can also, like, once you define all of this, in the what FLAML will do is that it will generate the configurations combination and use your user function to compute the performance, and it will get the performance based on the function, and it will select another combination of the hyperparameters based on the output of the performance from the search space. So it will iterate on this, and then finally it will give you the best config. And also, so this is basically the generic HPO. We have, like, you can use it for the machine learning workflows pipeline. It's already, I think, for like, I don't know if you know Databricks. Databricks, so MLflow is actually open sourced by Databricks, and the Databricks also integrated FLAML into MLflow. So for solving the pipelines, because in MLflow, it also provides some pipelines for machine learning workflow, and it can help you do the so in that pipeline, you just need to, like, also define the task, define the data, and this will give you the models and also the prediction endpoints. So from MLflow, and for finding the best models is actually backed by FLAML. So, and it can also be used for many other cases, scenarios, like if you are doing reinforcement learning, casual models, and if you are doing simulations in environmental science. So what we have right here is actually we have get some feedbacks from our users, from FLAML's community, that some of the customers saying that they are using it they are using FLAML to do these scenarios and get some good results. So this is also the feedback that we wanted to have, and this is the feedback that's encouraging us to keep working on this project. And also, yeah, so to summarize the benefits of tuning in FLAML, we have like minimized the, so I will not read it. It's just like what we similar to what I have already read for AUTOML. So like the manual effort and efficiency, and also the flexible. Okay, so now let's I will introduce some advanced features in FLAML, like the parallel training and with Spark, and also I will give you an example of customizing the estimator and the metric. And also, so actually we have just see the experiments and model checking with auto logging. So FLAML supports two kinds of parallel training. One is Ray. I don't know. In Microsoft Fabric, we don't support Ray, but Ray is also an open source project that supports parallel training. It's a great project. If you want to accelerate the training process of your, I think, all kinds of machine learning tasks, not only for AutoML, you can try Ray. And Spark is also another framework that Spark is highly used in the big data scenarios. So it can also handle it can handle big data, and it can also be leveraged to do the parallel training for FLAML. And we have two kinds of parallel training for based on Spark in FLAML. So like one is that, like if you are using models like sklearn, like GBM, so we call this non-Spark estimators. You can use it to parallelize your training by setting use Spark to true, and add the, so this unconcurrent trials. This is just how many trials you want to run in parallel, but this will be depending on the Spark cluster you are running on. If your Spark cluster only have like one executor node, even you set it to 3, it will only trigger one trial at a time. But if your Spark cluster like have 20 nodes, you can set it between 1 to 20. And also, if you are familiar, or if you want to use Spark based models, so the models inside PySpark.ml or SynapseML, you can do it with we have this util function, to pandas on Spark, help you to transform the pandas data frame into the pandas on Spark data frame. And so in that case, you will train one model at a time, but because the model itself is based on PySpark or SynapseML, it's the model. The model itself will be trained in parallel. So in the left, if you are doing non-Spark model, you are training different models in different nodes, but it's like a model parallelization. So for each model, you have all the data set. But in the right side, if you are using a Spark model, it will split the data set into different nodes and train your one model in the clusters. So this is like data split, two kinds of parallelization. Yeah, and what we need to know is that parallel training is not always better than sequential training, because you will introduce the overhead, like the communication between different trials, different nodes, and also the parallel resource may itself may have some other overheads, and also it will be much harder for you to reproduce your results in parallel training. So in this case, we can see, so this is the case that for each trial, it just costs like 0.2 seconds. But the wall clock, so the wall clock means the actual time you spend is much longer than the the trial time. So in this case, sequential tuning is much faster. So just keep in mind that parallel tuning is not always better. Okay, so the next we will covering. I will give you some examples about how to customize the estimator and the metric. So if you don't find the estimator that fits your needs inside FLAML, and you want to extend and create your own estimator, you don't need to like change the code of FLAML. But we will welcome your new contributions. But before that, you just need to extend the estimator. So in this case, I will extend the sklearn estimator, but with the regularized greedy folders. So I will define what kind of task it will support, and also what is the search space for this model. And also, you can also like define the fit function and the predict function. That you can check the documentation of FLAML to find more example. But this is basically the most important things that you want to you need to change to create your new estimator. So once you have this class defined and you want to use it in your training, you just use this add runner to register this new runner into the FLAML's estimator list. And then in the settings, you need to manually add in your new runner into the estimator list. So in this case, you can use the new estimator to do the training. So let's go back here. So here, this is where we customized the model. Let's run it. And I think let me run it again. Yeah. Cool. And here, oh yeah, let's go back to let's customize the metrics together. So to customize a metric, like if you want to use the better metric for your own case, you can also do it. So you will always. So this is the input. You will always have all of this input as the parameter of this customized metric function. But you don't need to use all of this information. Like in this case, we didn't use the config groups value and the groups chain, and so we will use log loss to compute the loss, and we will also pass more information back. So we'll return the value loss and chain loss and also the prediction time. So this is optional, but in this case we use the validation loss and also the training loss altogether at the loss. So, and you need to so in the metric, so in the settings, you just pass in the function you define for computing the loss. If you can, so this can be a string or a function. If it's a string, you can say like accuracy or log loss or RMSE or all kinds of metrics here supported in FLAML. But if you want to define a new, you just pass in the function. So now let's go back into the demo. Yeah, and here I defined exactly the same metric. And I will add the runner, and also define the estimate, add it to the estimator list. And also the metric is changed. So we can do the fit again. And also you can see that, so here in the estimator list, we can see that RGF already in it. So it will start with, so the current runner is RGF. And so now it's trying with, okay, we get a run finished. So the estimated estimator RGF, and so it will try RGF again. And we can it will also take maybe 2 to 3 minutes to finish the running. And we can see that. Okay, so because this data set is quite simple. I mean, when I say simple, I mean there are not a lot of rows of data. So the data set is small, and the features we don't have a lot of features. We have several. Yeah, we see a better so lower loss. So it's becoming better. And also, so I think I have a little bit, I need to go faster. So when we are waiting for the results, let's go continue with the slides. So this is the experiment and model tracking we have already seen, so I will not do it again. And oh yeah, we can also see there is another view of the tracking. You can actually compare all the metrics or loss that you want to compare with this figure. And yeah, so this is the notebook we have. We have already introduced it. Let me see if the running is finished or not. Okay, I think it's going to be finished. So while it's still running, we can check the result, the output. Let's see. This is the one is running, and also we can see the view. You can see the run list, and if you click all of them, you can see because we don't have, like, if we just compare this one, so you can see this is the run name and this is the parameter. But for this completed, I think you can also see some. Okay, yeah, you can also, so this you can see the accuracy and the loss. So here, let's see, I think it's already, yeah, it's already finished. So, and also you can print out the configurations and its accuracy. Just the code will always be the same. So next, let's go to the, yeah. So the last part, I will introduce some advanced features. So for this is only accessible inside Fabric. So I will go a little bit faster on this part. So, but if any of you are interested, you have registered an account, you can try it. So we just need to add one more parameter in the settings. So set visualization to auto. Then you can enable the auto visualization. So auto visualization is a little bit more than like compute, more than fill in the missing value. It will like do some transformation on your data. If you have categorical data and you have the stream data, it will do the maybe do some one-hot encoding, and you can also compute the. I will show you the code directly, and like here you can see all the introduction of the model, and you can also like to scale the computers. Use some like min-max scaling scaler to transfer the features, and you can also do feature selection. So not necessary to use all of the features, and also you can do some highlight advanced transformation like PCA or LDA. So these are already integrated in FLAML, and let's try it. So I will use false here. So because when we set it to auto, at least for this data set, in the end there is no visualization, because it turns out that without visualization the performance is better because the data set is very clean. So here I use false to make sure that we will see the visualization. Okay, so I didn't change any other settings. So this is still the customized matrix, and this is the estimated list. We just add this visualization, and we'll see what we got later. Yeah, so it's boring, waiting for the results. Yeah, let me check the. I can go back here later. Yeah, I will. So we also have the visualization. So for like you want to see the like the optimization history, the feature importance, error coordinates, and control. So we have 8 kinds of visualization supported now. I will then to use it is also very simple, and we can check it once this is finished. Okay, I think it may be the last trial now. Okay, cool. And then we can check what we got for the visualization part. Oh, yeah. I think I'm not sure if I change this and rerun it because it looks like also I changed it to false, but I ran it before I change it. So I mean, the visualization is actually maybe auto, and the result is like there is no visualization here because it's none. Because for this data set, the best configuration is that you don't do auto visualization because the data is already very clean. And I wanted to force it to use a visualization, but I think I missed the order of the code. Because of time, maybe we can just check it here. So what you will see is like you will get the normalizer and this remainder. So for anything in the remainder, it means it will not be changed. But for anything here, you can see that the column of the data will be transformed based on the different kind of transformers. So like in this case, you can see the data transformer and you can see the visualization. And for this is another data set. You can see in the end, there is also the selection based on the variance threshold. So it will use this method to select the features for you. So like you have maybe 100 columns of data, but in the end, only like maybe 15 or 50 features will be selected into the final training. And also, so for the visualization, you can, we have like this, we have actually 8, and you can see it's very simple. So import from FLAML visualization, you import the module and you can plot slides and pass in the AUTOML instance that would make it. And also this different kind of model, different kind of plots. And maybe like this one. So like for this one, this is the optimization history, means so this is the best score. Best score is actually the loss value. So it's becoming lower and lower, and you can see it. So this is actual score of the current run, but the red line is the best one ever. So in the end, this one is the best one. And also, yeah, and also this is the feature importance. So you have a lot of features. So this one tells you that the most important 2 features here for this model, that the time and the airline can help you to predict the whether a flight will delay or not. I think this makes sense. So you want to choose a better company to like the, so for me, Air France and Air China are the good ones to choose. I will not choose airline I never heard. So to fly to Paris, right? And the time is important. So if it starts at a good time, usually it will arrive at a good time. And for this one, you can see the like at each time. So what is the different kind of parameters and the related final score? So yeah, so this is the tutorial. Another one is for the large language models, but I will go through it. Okay, maybe 3 minutes. And yeah, for the large language models, we have different kind of inference parameters to tune it. Like you want to choose different models, you want to use different temperatures and the prompt length, and also you have different, like you have several prompts that you want to choose, and you also have some in context learning, like for the few short learning, you have some examples. Like you have maybe you have manually set as, let's say, 20 different examples, but you don't want to feed all of the examples into the prompt. Maybe you want to choose 5. So which 5 would work best? So this is, all of this can be modeled into a tuning function. And we have supported tuning in FLAML, and you can use it with this API. And also I will show you this. I will not run this because we don't have enough time for the live session, but we can see the result. So like you can install the, so for now it's only OpenAI smaller than lower than version 1 is supported. And here, so you need to set, so in Fabric, you just need to give the model name, and that would be okay. And then so we can check if the configuration is working. Okay, this model is working. And here the data set is like it's a mass data set. So it's a, oh sorry, I should not run it. The questions is like this. This is the problem, and the solution will look like this. How to solve this problem? And you need to define a success metric. Means you need to write your own evaluation function, so that we know whether an answer is good or not. And then you can perform the tuning. You just choose. So this is the default search space, and you can update it by yourself. So here I updated it. So like I don't have GPT-4 or GPT 3.5 because GPT before that we have it, but now these models are deprecated. We now have GPT 3.5 tuber, and I use this one. And I have also defined the prompt template. So I will fill in the problem and get a solution. And also I need to let FLAML know what's the price of inference and so the input output, so the prompt and the inference price for the model. And then we can start the tuning, just to fill in the data set. And this is the process. Like for different child, it shows different temperature, max tokens, and the number of returned results, and some other things. So in the end, you can get optimized configuration. So because here I only have one model. If you have different models, you can put that into the search space as well. So this is the final solution for this. And what is the performance? Right. So this is, here we can see we compute all the so we compute the performance on the on the test data with this best configuration. And you can see that performance on test data from a default configuration, the success rate is 0.78. And if so, with for the tune performance default, and I think I forget to print. Oh, I did. Yeah, this is for the default configuration, but for the tuned configuration, it's 93% of success. So you can see that at least for GPT-3, it's worth tuning the inference parameters, and you can improve the performance. So I think this is basically the better than the performance of GPT-4. So, and it only cost well, how much is it? You cost less than $1 to get the better configuration for the model. Yeah, so give it a try. Thank you. I think this is the final demo. Yeah, and we are calling for contributions from the community. Thanks to all the contributors. And yes, the last slide. Thank you.